Hello class! Our topic for today is solving problems involving permutation and combination. This is for grade 10 mathematics, third quarter, module 5 from version 5. I am your teacher, Anthony G. Arisgado, teacher 3 of Bukidnon National High School. This video is for Icon Live Malay-Balay and of course, for you students of the Department of Education. The objectives for today's lessons are solving problems involving permutation, circular permutation, and distinguishable permutation. Also, solving problems involving combination. Now, this video lesson contains activities and assignment, of course. Let's go! For permutation of n objects taken r at a time, the formula is given by this. The permutation of n objects taken r at a time is equal to n factorial divided by the quantity of n minus r factorial. Take note that the permutation of n objects taken r at a time can't be written by NPR. Okay, let's use the formula in solving this example. In how many different ways can 6 motorcycles be parked if there are 10 parking spaces provided? In this case, we are going to take note of the given. So we have n equals 10 and r equals 6 for the 6 motorcycles. Then of course the formula. Now in our formula, n there is always greater than or equal to r. R cannot be greater than n. Okay? Substituting our given, it will be the permutation of 10 objects taken 6 at a time is equal to 10 factorial divided by the quantity of 10 minus 6 factorial. Simplifying 10 factorial is this, 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial because our divisor is 4 factorial. 4 factorial divided by 4 factorial is equal to 1. So simplifying, we have this. So the permutation of 10 objects taken 6 at a time is equal to 151,200. Therefore, there are 151,200 ways to park 6 motorcycles in 10 parking spaces. As simple as that. For circular permutation, our formula is given by P equals the quantity of n minus 1 factorial. Okay, our problem. A couple wants to plant some shrubs around a circular walkway. They have 7 different shrubs. How many different ways can the shrubs be planted? Given is n equals 7 with our formula. So substitute 7, it will be the quantity of 7 minus 1 factorial. P is equal to 6 factorial, which means that 6 is 6 times 5 times 4 times 3 times 2 times 1 equals 720. Therefore, there are 720 ways to plant the shrubs around a circular walkway. Let's proceed to distinguishable permutation given by this formula. Now, the n there is the total number of objects. The q, r, s are the repeated objects. Just like in the example. In how many ways can you arrange the digits of 120,022? So by solving this, we are going to identify the given. Given 2 is repeated 3 times and 0 is repeated twice. And the total number of digits is 6. Then let's substitute this to the formula. It will be like this. So 6 factorial divided by 3 factorial for 2 repeated 3 times and 2 factorial for 0 repeated twice. So simplifying, we have 6 times 5 times 4 times 3 factorial for 6 factorial, because we have 3 factorial in our divisor, then times 2 times 1. Simplifying, 3 factorial divided by 3 factorial, that's 1. 4 divided by 2 times 1 is 2. So simplifying further, we have P equals 6 times 5 times 2 equals 60. Therefore, there are 60 ways to arrange the digits of 120,022. Okay, so we have 3 problems for permutations. Now let's proceed to combination. Now for the combination, our formula is the combination of n objects taken r at a time equals n factorial for our dividend, and our divisors r factorial times the quantity of n minus r factorial. Take note that it could also be written as NCR. Now for our problem, if there are 7 ice cream flavors available, in how many ways can Dave choose 4 flavors? So identifying the given, we have n equals 7 and r equals 4. Substituting the given to our formula, it will be the combination of 7 objects taken 4 at a time equals 7 factorial divided by 4 factorial times the quantity of 7 minus 4 factorial. Simplifying, 7 factorial is 7 times 6 times 5 times 4 factorial, because we have our divisor as 4 factorial, times 3 times 2 times 1, 4, 7 minus 4 factorial. Simplifying further, we have 4 factorial divided by 4 factorial, that's 1. Also 6 divided by 3 times 2 times 1, that's 1. So, our combination of 7 objects taken 4 at a time is equal to 7 times 5. That is equal to 35. Therefore, there are 35 ways can Dave choose 4 flavors out of 7 flavors of ice cream. Simple, right? So let's have our activity. Let's do this. Analyze and solve each item. Find the number of distinguishable permutations of the letters of the word committee. Number 2. In how many ways can you arrange 9 pots in a row if taken 4 at a time? Number 3. In how many ways can a committee of 9 students be chosen from 8 juniors and 10 seniors if there must be 5 seniors in the committee? And number 4. How many students are there if their number of arrangements around the circular table is 24? So I hope you can identify which is distinguishable permutation, which is a permutation of n objects taken r at a time, which is circular permutation, and which is a combination problem. Okay, let's solve number 1. So find the number of distinguishable permutations. So it is stated as distinguishable. So we can make use of the distinguishable formula where n is equal to 9 for the word committee, for the letters of the word committee. Then we have M, T, and E are repeated twice each. Okay, so it will be like this. So n is 9. So 9 factorial divided by 2 factorial divided by 2 factorial and 2 factorial. Okay, so simplifying, our 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 8. So we can divide 8 by 8. So that what's left there are the following factors. Simplifying, we have P equals 45,360. Therefore, there are 45,360 distinguishable permutations for the letters of the word committee. Get that? Very good. Let's proceed to number 2. In how many ways can you arrange 9 pots in a row if taken 4 at a time? By the word arrange, so we can have this problem as a permutation. The given n equals 9, r equals 4. So the formula is this one. So substitute, we have the permutation of 9 objects taken 4 at a time. 9 factorial divided by the quantity of 9 minus 4 factorial. Simplifying, and then 5 factorial divided by 5 factorial, that's 1. And then it will be 3024. Therefore, there are 3024 ways you can arrange 9 pots in a row if taken 4 at a time. Number 3. In how many ways can a committee of 9 students be chosen from 8 juniors and 10 seniors if there must be 5 seniors in the committee? Take note of the given. So we have 2 n's, so 8 juniors, so that's our n sub 1, and n sub 2 is for the 10 seniors. Now we have our r, there are 4 juniors because there must be 5 seniors in the committee. So take note of the word chosen or choose. This problem is a combination problem, but a little bit complicated because there are 2 sets of given. So how do we do it? So by doing this, we have our formula, combination of n objects taken r at a time. Substitute the first given or first set, n sub 1 and r sub 1, and then our n sub 2 and r sub 2. Now, if we're going to solve problems involving 2 combinations, we are going to multiply. Okay, so we have our factors. First factor, the combination of 8 objects taken 4 at a time. And our second factor is 10 objects taken 5 at a time. So, simplifying, we have this. 8 factorial divided by 4 factorial times 4 factorial. Okay, and for 10 objects taken 5 at a time, we have 10 factorial divided by 5 factorial times 5 factorial. So, we have 70 times 252 if you're going to solve. And the answer will be, okay, so 17,640 ways. Therefore, there are 17,640 ways to make a committee of 9 students from 8 juniors and 10 seniors if there must be 5 seniors in the committee. So this problem is kind of challenging, but please understand how I solve this and apply this in the later activities or problems. Number 4. So we have this problem, how many students are there if their number of arrangements around the circular table is 24. So we have this given, p equals 24, and we do not know the n. Using the formula, we can substitute 24. 24 equals the quantity of n minus 1 factorial. Now, 24 can be written with the FCP or the factorial form. So we have this 1 times 2 times 3 times 4 equals 24. Then copy the quantity of n minus 1 factorial. Simplify, the 1 times 2 times 3 times 4 is just the same as 4 factorial. Now, both sides of the equation has factorial, so we can just remove that so that we can solve for n. Okay, to solve for n, we can just change the position of n minus 1 and 4. So we have n minus 1 equals 4. Then solve for n. N is equal to 4 plus 1, where n equals 5. Therefore, there are 5 students seated around the circular table when their number of arrangements is 24. Okay? So, as simple as that. If you have questions, class, then you can post it in the comments section. Okay? So, that's the activity for the day. For your assignment, please solve these 4 problems. And I hope you understand each problem and you can use the formula fitting for it. Okay? Thank you so much for watching this video. I am your teacher, Anthony G. Arisgado, Teacher 3 of Bukidnon National High School, saying Thank you very much. And class, please don't forget to subscribe, like, share, and comment on this video. This video is for Icon Live Malay-Balay, where math is fun and math is for everyone. Bye-bye!